Welcome to David Alexander Maths Tuition. This is Chapter 1C on factorising. So what we need to remember is that factorising is the opposite of expanding brackets. So we are going to be creating brackets. So if we look at the first example, x squared plus 4x, what is common to both terms? What can we divide both terms by? Well, the answer is x. So x is going to come outside the brackets, and inside the brackets, well, what is x squared divided by x? X squared divided by x is x, and 4x divided by x is 4. And if you want to check, because expanding brackets is much easier than factorising, just expand the brackets. X times x, x squared, x times plus 4 plus 4x, easy peasy. With the next example, let's look at the numbers first. What can we divide 8 and 2 by? Well, the answer is 2. What can we divide x to the power of 4 and x squared by? Well, what's the lowest power here? X squared, so we can divide both by x squared. So, what is 8x to the 4 divided by 2x squared? Well, 8 divided by 2 is 4. X to the 4 divided by x squared is x squared. Plus, what's 2x squared divided by 2x squared? Well, anything divided by itself is 1. Okay, so here we are factorising x squared minus 16. Now this is called the difference of two squares. X squared is obviously a square and 16 is a square number, and there's a minus sign in between. So we need to remember that this will factorise to x plus 4 square root of 16, x minus 4. If we expand the brackets, in the inside we get plus 4x, and on the outside we get minus 4x, which means 0x, and you can see we've got 0 x's there. So the next one, we've got a square minus another square. So what's the square root of 49? That is 7. Square root of x squared is x, of course. So that's going to be 7x in both brackets. The square root of 36 is 6. So 7x plus 6, 7x minus 6. And this final example, we need to appreciate that both of these are squares. X to the power of 4 is x squared, and y to the power of 4 is y squared, all squared. So that will become x squared plus y squared in one bracket and x squared minus y squared in the next bracket. Not particularly obvious, that last one, because you don't see anything to the power of 4 as something squared, of course. So here we are factorising quadratics. So the key is we are looking for multiples of 24 that add up to 10. Okay, so if you need to, write out a list. So 24, that can be 1 times 24, 2 times 12, 3 times by 8, 4 times 6, 5 doesn't go, 6 does, 6 times 4, but 6 4s are the same as 4 6s, so we are done. Now, how can I get a 10? I can't get a 10 with a 1 and a 24. I can get 10 with a 12 and a 2, but that would be 12 take away 2, and minus 2 times 12 would be minus 24, and we want plus 24. So it must be 4 and 6. So therefore, it's going to be x plus 4, x plus 6, or x plus 6, x plus 4, it doesn't matter. Let's look at this next example. Let's focus on the 20. Let's not panic that it's negative 20. So that's 1 and 20, 2 and 10, 3 doesn't go, 4 times 5. So I'm looking for ways to get plus 1. Now remember that one of them needs to be negative, because actually I'm aiming for negative 20. So I can't get a 1 with a 20 and a 1. I can't get a 1 with a 2 and a 10, but I can get a 1 with a 5 and a 4. It's 5 minus 4. So that'll be x take 4, x plus 5, or the other way round. When I mean the other way round, x plus 5, x minus 4 is fine. As long as the minus is with the 4 and the plus is with the 5, we're good. Okay, so 3x squared plus 10x take away 8. So what I would probably do myself is, because 3x squared can only be generated by having a 3x in one bracket and an x in the other, I would personally just guess. Just trial and error. Now a number needs to go here, of course, and also a number here, but the number here needs to be tripled. So factors of 8, 1 and 8, 2 and 4. So I'm looking for a number that is tripled. One of these numbers needs to be tripled in conjunction with the other number to give me a 10. So for example, if it was a 1 here, that would be triple 1, so 3 and an 8 are not giving me 10. So how else could I do that? So actually this one's a bit confusing, because, well, quite a lot of them are a bit confusing actually. If I tripled the 2 I get 6, and 6 plus 4 gives me 10, but actually I'm aiming for negative 8, so one of the numbers also needs to be negative. So if I tripled the 4 I get 12, and then if I subtract 2 I get 10. So there we go. So the one I'm tripling is the 4, so that needs to go on the outside because that is the one that's being tripled, and this will be 2. So 3x minus 2, x plus 4. Now, maybe you didn't enjoy all that trial and error. So here's another way we can do it. Multiply 3 by 8. 3 8s are 24. What are the factors of 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. So what is another way how can I get 10 using any of these? Now 3 times negative 8 is negative 24, so one of the numbers actually maybe turn that into minus 24. One of the numbers must be negative. Okay, so I'm looking to get 10 and not by adding. So what I mean is I can get 10 by 4 plus 6, but that would mean both are positive, and 4 times 6 is not negative 24. So the only way I can get 10 is 12 take away 2. So what I'm going to do is 3x squared plus 12x take away 2x minus 8. So all I've done is I've written 10x as 12x take 2x. I could have written take 2x plus 12x, by the way, that would also have been fine. Now I'm going to do a chop down the middle, and I'm going to factorise each side. Now this left hand side I can divide through by 3x, so that's 3x lots of x plus 4. And here I can factorise out, I can divide by minus 2, so that's minus 2 lots of x plus 4. Now, these brackets need to be the same. In fact, knowing that this had to be x plus 4 helped me know how to factorise it. Expect these brackets to be the same. If they're not the same, you've made an error. So x plus 4, that is one of the factors. And the other factor is 3x take 2. Of course we knew that already, we've already factorised it, but that's another way of doing it. Let's look at another example. So this one I wouldn't guess, because 3x squared is easy. It must be a 3x and an x, but a 12x squared could be a 12x and an x. It could be a 6x and a 2x, it could be a 3x and a 4x. So there's far too much guesswork going on here. So let's do 12 times by 5, which is 60. Factors of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And how can I get a negative 17? And one of the numbers must be negative. So 20 minus 3. 20 times minus 3 gives me that minus 60. So I'm going to write 12x squared plus 20x take 3x take away 5. 20x take 3x. No, I've got that completely wrong. Let's try that again. That should be 12x squared minus 20x plus 3x take away 5. I knew something was troubling me there. So karate chop down the middle. Let's factorise the left hand side. We can divide by 2 and x. That is 2x. Actually no, we can divide by 4. So this one's not going very well, is it? So 4x brackets 3x take away 5. And okay, I need this bracket to be 3x minus 5. So that's going to be a plus 1. Bit weird, we're sort of factorising 3x minus 5 just to turn it into a plus 1 lot of 3x plus 5, minus 5 rather. Really struggling with the signs here, because we need these brackets to be the same. So one factor is the 3x take away 5, and the other factor is 4x plus 1. And we are done there. Okay, factorise completely. 3x cubed plus 13x squared plus 4x. Now first of all, I can see we've got an x in all of them, so I can divide through by x. So that will leave me 3x squared plus 13x plus 4. Now I just need to factorise this. So 3 times 4 is 12. Factors of 12 are 1 and 12. In fact, I can already see that the 13 is going to be the 1x plus 12x. So I'm going to write that as 3x squared plus 12x plus 1x plus 4, or plus x plus 4. Chop down the middle, factorise the left hand side, that's 3x lots of x plus 4. And here, if I'm I need a bracket of x plus 4 to match the x plus 4 there, so that must be plus 1 x plus 4. So one factor is the x plus 4, of course, and the other factor is 3x plus 1. and the other factor is simply x, which you can put in brackets if you really want to, but doesn't need to be in brackets. So x, 3x plus 1, x plus 4. And again, if you're not sure, expand those brackets and you should end up back where you started.